This is part 2 of lesson 4, identifying characteristics of linear functions from a given equation. So the goal for this lesson is to identify and describe characteristics of a linear function or a straight line. We've been looking at what is the leading coefficient, the slope, the end behavior of that function, the y-intercept, the x-intercept, the domain and range. As in the previous lesson, we said equations that have straight line graphs are called linear equation. Sometimes these are referred to as linear function. So we can determine a lot of information from the graph of the function just by examining the equation. In the previous lesson, we determined the slope of the line, the y-intercept. Today we'll extend that and looking at what's the leading coefficient, what's the x-intercept, the domain and range. So there's a lot of information we can determine about the relationship in the data just by studying the equation itself, as from the graph of the equation. So let's look at an equation that we can examine. Let's look at a basic. So we're going to enter into your calculator. So let's look at step 1. We're going to enter this equation. Y is equal to 2x plus 3. So we will explore this equation. It's a linear equation. So step 1, we will enter the equation y equal 2x plus 3 into your calculator. So you're graphing whatever graphing calculator you're using. We use Desmos graphing calculator. Step 1. So we'll look at, so you'll need your graphing calculator or Desmos. So I'll zoom out a little bit so you can see the picture here. And the next step, we will sketch the graph and label the 2 points on the graph. So you may need a little bit of graph paper, such as this here. We'll sketch a graph, right? So you need a graph paper, a graphing calculators, or Desmos, pencil, pen, and a ruler. Then the next step, we'll sketch a graph. And we will label 2 points here. Two points on the graph. So let's go ahead and try that. Okay. So first we use the graphing calculator. So we'll use a little bit here. So my equation is y is equal to 2x and here is my Desmos. So both. Now, the first thing I do is, first of all, let's clear. This calculator is off, Desmos is on. So I turn my calculator on by pressing, and I can press 1, so do not show again. Somehow this still continues to show, but next, okay, let's adjust my camera here. like you to see the keypad for the calculator. So the first thing we want to do, we would like to input our equation y equals 2x plus 3 into my calculator. So in your graphing calculator, you want to press the y equal button first. Then I type 2, and this is your x button here. Right here. 2x plus button across here, 3. I'll go to Desmos, and I'll do the same thing here. I'll tap in here, but I have to type my y equals 2x. The graph comes up automatically. That's one good thing, one of the many good things about Desmos. Now a plus 3. So automatically you see your graph with Desmos. Now with the graphic calculator, when you type it in, you don't see your graph right away. You have to press your graph button here. So find your graph button and press that button there. And there is your graph. Notice this scale is from -10 to +10, and the negative 8.5 to +8.5. We can do the same thing here. You can go to your Windows and set your scale to -10. This is your negative button here, right? Don't put your subtract button, -10. Your minimum, your maximum here is +10, enter. And your y minimum here is negative. Let's make that, give it as -5, that's fine. And y maximum is also 10, so we keep it, leave it as that. So notice this y-intercept, if I tap on here on my Desmos, I see my y-intercept right away, which is 3. And that matches up to our equation here. Remember, that's your y-intercept, and this will be your slope. So your y-intercept is 3, and your slope is 2. So it's a positive slope, the rise of the run. If I were to zoom in into calculate here in the Desmos, you could if you look at Desmos now, this is your point on the line, which is 0, 2, and I can tap on it. Yeah, go back here, tap on that point, and show up. So this is 0, 3. Now tap on this line there, -1.5. This is your rise is 3, and your run is -1.5. So 3 divided by 1.5 gives you 2. Okay. Another way of looking at it, tap on that point there. This is a much easier one to read. Okay. Tap. Okay. Doesn't want to show up. Okay, so we have to try that one again. And there you are, those points. So the rise is 3 and the run is 1.5. So 3 divided by 1.5 is 2. That gives us a slope. That's your y-intercept. In your graphing calculator, you'll have to find your y-intercept differently. You can look at it and you can see it's 3, but to find your y-intercept, you have to press your y trace button, enter, and let x be 0. Now, when x is 0, that's on the y-axis, and that will lead you to find your y-intercept. Now, when x is 0, what is y? You press enter, and y is 3. So your y-intercept is 3. That's exactly what we have here. Your slope is 2. Okay. So there, using the calculator, we enter that into our calculator, we find our slope. Now, what is my x-intercept? Right. So now we found our y-intercept. So let's write that down. So first of all, we're going to sketch the graph. We're going to sketch it here. So this point here is 3. And from our Desmos, we see that here is negative 1.5. Here we have 1, 2, negative 2, and negative 3. Oops, can be negative. Can go backwards here. Negative 1, this is 0, 1, 2. So it's right here. So this is my sketch. That's my line. That's my y-intercept. Now I can continue this to be 2 here. 1, 4, 3. We label 2 points on the line. I can label this. This is my y-intercept. Okay. See, for my Desmos, that's my y-intercept. So y-intercept is equal to 3. My x-intercept, now notice what happened here. X is 0. So whenever your point has x is 0, that indicates your y-intercept. For example, if I were to go to this point here, at 2, x is going to be 0. Anywhere along the y-axis, x is 0. My x-intercept, where it crosses the x-axis, it's negative 1.5. So if I tap on this here, and so y is 0 and x is negative 1.5. So this is my x-intercept. That's using Desmos. So Desmos is pretty straightforward. Once you have your graph, you just tap on the y-axis where the line crosses to find your y-intercept, and on the x-axis where the line crosses the x-axis, that will give you your x-intercept. So that's Desmos once you have the equation in. So we have our equation. Now, so we can write it down here now. X-intercept equals negative 1.5. So you can write a coordinate plane as negative 1.50. That's a coordinate for that. Now, the y-intercept is equal to 3. Or we can write it as x is 0, y is 3. Now, when we talk about the leading coefficient, right? The leading coefficient is a slope here. As long as in this form here has been the standard form, so the leading coefficient is 2. So that's your leading coefficient. It's a value in front of the x-axis. Now, the end behavior. Let's look at another one here. End behavior. So I put 2 here so we get the same line. Now, the end behavior refers to the quadrant. Remember the first lesson we looked at regarding correlation coefficient? We said the coordinate plane is divided into 4 sections. The sections are called quadrant. This would be quadrant 1. Okay, here. Quadrant 1 is here. Quadrant 2, so Q. Quadrant 3, and I should have written it in Roman numeral. And this is quadrant 4. Should be 2 here. quadrant 2. So in this graph now, it's going from quadrant 3 to quadrant 1. And the way you label where it's heading to, you're looking at where it's increasing, the x increasing. What is the y? What is happening with the y? Because as x increases, y increasing, we say it's moving from quadrant 3 to quadrant 1. So the end behavior is from quadrant 3 to quadrant 1. So just by looking at this equation, finding the intercepts and doing a sketch, we can tell a lot about the graph. Now, we haven't looked at domain and range. That's the next one. Now, let's go to your graphing calculator. Now, Desmos, I showed you how to use your Desmos to find your intercept. Now, you'll have to go back to your, if you remember your sheet regarding using the calculator. And let me find mine. Okay, so look back at this sheet you needed. And on the first page, just using the graphing calculator, how to find the x-intercept. Okay, so let's find the x-intercept. Now, we have our equation in the line. So we'll move this for a moment from here. So this is our equation, which we have in our calculator. So we like to find, let's look at just the x-intercept on this page here. The y-intercept, you'll have to go to the next page here. Okay, to find the y-intercept. So we'll find the x-intercept and the y-intercept first. So let's find the x-intercept first. Okay, remember your Desmos was simply tapping on the y-axis where the line crosses, or tapping on the x-axis where the line crosses, and that will give you the value for your x and y intercepts. Now, to find a value for your y-intercept, which is find determinant of the y value. Now, let's release this one here, more previous question. Determine the y value. Now, remember, we said that the y-intercept zoom in here. The y-intercept x is 0. So if you want to find y, you let x be 0, right? The y-intercept x is 0. You let x be 0 to find y. So we'll be using how to determine the y value to find the y-intercept. So x in this, so the x-intercept, so the y-intercept is a special case now. For the y-intercept, let x equals 0 to find y. So first step, enter into your equation, which we did. Second, trace calc, choose value for 1. Type whatever value for x you're given. We want that x to be 0. Press enter, and that will give us our y-intercept. So from our Desmos, we said the y-intercept was 3. So let's see if we're going to find the same value. We should, or else we are in. So I'll zoom back out so you can see whatever key I'm pressing. So we already have our equation, which we've put into our calculator at the beginning. Now we are going to follow the steps, determine the y value for the y-intercept. So enter equation, which we did here. Then we'll press graph. We'll have a graph there. Make sure your window is fine. Then you press your second button, trace. Second trace. And we choose 1 for value. Enter. Once we have that screen, we're going to enter x equals 0 because we want to find this point on the y-axis. This line here, x is 0. So when x is 0, type whatever x value you were given. In this case, x is 0. Press enter, and y is 3. So that's the way of finding your y-intercept. Okay. Now, to find now there are 2 ways of doing this. But we determine the x-intercept. Go to the first page. Now we're back to the first. Now we want to find the x-intercept. Now we have our equation back here. So this instructions are for general. We'll work through this one. Enter equation in the y1, which we did here. Now this is critical. Line 2 said enter equation in y2, y equals 0. So we move down by pressing the right down arrow key, and you enter 0 there. Now, what you're doing in reality, go back to this equation, you have 2 equations. You have y equal to 2x plus 3, and you are also putting another line here. Right? Y equals 0. This would be the line right on the x-axis. And the next step, we are going to find where these 2 lines meet their intersecting point, and that will give you your x-intercept. So that's why it's critical for you to put another line here. You want to find where these 2 lines meet. Desmos do that without all those steps, right? Easily by just tapping. The graphing calculator a little bit more, a few more steps. Now the next step, we go to second trace. So second trace. Now we move down to 5. We want to find where this line intersects. And there are 2 lines. So we go down to 5. You can move down, or you can press 5. Press enter. Now, in my calculator, because it's a colored one, I have a red line here. This indicates y equals 0. And this is y equals 2x plus 3. I need to find where these 2 lines, the red line and blue line, meets. And this is where you will press, it will say first curve, you press enter. Second curve, you press enter. The next one, you press enter. And that's your x-intercept, which is negative 1.5. So let's do it again. So I go back to my graph, y equal, and I go down to intersect. Now, in this case, it's already found it here. It's already there, but I'm going to do that 3 times. 1, 2, 3. X equals negative 1.5. So that's how to find the x and y intercepts using the graphing calculator. Okay. Now we'll do another example, and this is in your booklet. So we'll start all over again here. I'm going to reset my calculator. I'm going to now just a reminder for those of you using the graphing calculator. With your Desmos, all what you have to do is to hit the X button, and that will clear your screen. The calculator is a little bit differently. You have to press your second button here and the plus. And then we go to reset. So I'm resetting my calculator. You don't have to do it all the time. Press all RAMs, press number 2, and this is on your instruction sheet here, number 1. And RAM is cleared. I do that now, whatever I had before, it's not there anymore. So let's follow the instruction. I'll follow the instruction from the graphing calculator for the graph, and because Desmos is a little bit different, but this is for the people who have a graphing calculator. So if you're given an equation, you can enter it in the calculator. So this is your y equal button. So when you turn your calculator on, you'll see, assuming you have a blank screen. If you don't have a blank screen, you can press your clear button, and it will clear everything. But once you reset it, you should have a blank screen. So we need to get to this screen here. So we press your y equal button. Right, it says press your y equal button screen. Come up here. Now to graph the straight line, y equal to 2x minus 3 now. We're going to negative 3. We put y equal to 2x minus 3. And we enter into our enter button, and our screen appears as this here. To find your y-intercept, remember, find your y-intercept, we follow the instructions here. We'll let x be 0. So we second trace, x be 0, y is negative 3. So our y-intercept is negative 3. To find now your x-intercept, go back to this instruction here. X into 1 at a time. We now go back to my y equal button. Let line 2 x equals 0. Press graph. And now I see 2 lines. Now, if you have a TI-83, you may not another a one does not have different colors, you will see this red line. But if you have a newer calculator, you might see the red line. If you do, it means you're going to find the point where the blue and red lines meet, or the intersect. So next we're going to follow our second trace. Fine, go to number 5 and press enter 3 times. Now it says x equal to 1.5. Should be flashing, somehow it's not flashing. Let's try that again. Second trace, intersect, 1, 2, 3. There it is, x equal to 1.5. And that will give us our x-intercept as 1.5. There's another way of doing it. You can press your second table, and this gives you a table here of all of the coordinate planes that are integers. So to find, in this case here, x equals 0, y equal negative 3, that gives us the y-intercept. Now, because these are all integers, we don't have a whole number here. We don't have fractions. So in this case, this y-intercept, the x-intercept is 1.5. You will not see it in your table. You will only see your x-intercept. Okay, so that's using your graphing calculator. Now, if you look at our graph here, the n behaving quadrant 3 to quadrant 1, the leading coefficient is positive, so y is positive here. The slope rises from the right to the left. Sorry, rises to the right. So the leading coefficient here is positive, positive 2. The y-intercept is negative 3. The leading coefficient is 2, or positive 2. Now, this is where it'll be new to you, domain and range. Now, the domain, right here, I'll zoom in. So domain lists up all the possible x values of a function. So you'll find, okay, where on the x-axis, let's go back to this graph here. Here's your line. Your line is going from, technically it goes on forever. There's no restriction on this graph. It's going up forever. So domain refers to your x values of the function. These are my x coordinates. This is my x-axis. This is my y-axis. So domain are all the possible x values. Now, because this graph is going down forever and going to the left forever and to the right forever, we say that the domain here includes every single number you can think about. Rational, irrational number, you name it. There's infinite amount of number. And the way we write that, we can say x is an element, that means, right? Or belongs to an element. And a little bit of r, this r means real number. Now, real number in a number system refers to every single number you can think about. Remember one of the lessons we did, we looked at, if you look at the center, we have whole number. And it could be like what, 0, 1, 2, 3, 4 in the center. Then we have integers. These are positive and negative whole numbers, like -3, -2, -1, 0, 1, 2, 3. There's no fractions here. Then the next step would be rational numbers, which include the fractions. Things like fraction, including all of these numbers plus fractions. So we can have a half, or a -1/2, -1/4, 0, 1/2, 1, etc. And the next one will be irrational numbers. Irrational numbers like pi, numbers you cannot. So move this one here. So this refers to an element. So x is an element of real numbers. The next set of numbers would be irrational numbers. And this refers to like a square root of 2, for example, or pi. In other words, these are non-repeating decimals. The fractions here are repeating decimals, irrational, non-repeating decimal. All of these refers to real numbers. So any one of these numbers, you can pick a 1 or a -1 or -1/4 or a square root of 2 refers to real numbers. So because there's no limitation to the domain here, we can conclude that the domain is that x is a set of real numbers. So whenever there's no restrictions, we said the domain is a set of real numbers. Now, and it goes from -∞, meaning going from your left forever, and it goes to the right forever. The range will be the same concept, except now you're looking at the y-axis. So we say domain is a set of all the real numbers. Now, it's not always a set of real numbers. We'll see later on there are restrictions. If I were to cut this line off from here and here, then it wouldn't be all the real numbers. It would be all the real numbers within a domain, within a set of values. But right now, this one here has no limitations. The graph goes forever to the right, forever to the left. So therefore, it's all the real numbers. The range, on the other hand, refers to all the values going positive up and down. So that's why we can say all the y values you can think about are the real numbers. So there's no restriction. So the range, a list of all possible y values of a function, respect the up and down arrow. So this can go up forever and down forever. And as I mentioned here, however, be aware that we use linear function to model a real-world problem. The domain and range may be restricted to certain values for x and y. For example, someone who was born, a restriction is limited. So we look at situations where the domain and the range are restricted. So let's look at this example here. We're going to zoom in here a little bit here so we can look at. Okay. Remember, that's just sine of a leading coefficient. So we can say the sine, and this is your leading coefficient, right? Sine of so the sine of the leading coefficient is positive here, or sorry, negative, not positive. So negative. So remember your equation y is equal to mx plus b. So remember this is your slope or leading coefficient. And this would be your y-intercept. The sign in front of it here is positive, right? We leave this. So in this slope direction, now put this into your calculator. Let's see what happens. So we are going to calculator here. We'll zoom out. I'll clear my list. Oh, just a reminder for those of you who probably went too quickly there, I'll slow down. So I'll press my Y equal button and I clear. Now, if I had my, let's say, 5x in here plus 3, I had that before. I want to clear it, I just press my clear button. Now I need to input this into my calculator. I want to be careful. This is a negative sign. Do not use a subtract sign. You have to use the one in the bracket in your calculator. Negative 3. This is your x button plus 5. And press graph. Notice it's a negative slope, so it's going from quadrant 2 to quadrant 4. And it crosses the x-axis at, now we can read it off, but we'll find it using our second trace button. Value, we let x be 0, y is 5. So now we hear this is 5. Now we need to find our x-intercept. So where it crosses the x-axis here. So we have 1, 2, 3, 4. 1, 2, 3, 4. Negative 1. X and y axis here. Negative 2, negative 3, etc. Now we need to find where it crosses the x-axis. To do that, we put your y equal button, let y to be 0, that's your graph. And you follow from your instruction here. You're going to find the x-intercept. Oops. Clear. So second trace, we're going to find the intersect, press that 3 times, and it tells me 1.67. So 1.67 is about here. So use my ruler, and that will give me my line. And I indicated an arrow because there's no restriction on my graph. So this graph, so directly decreasing to the right. So decreasing to the right. Now, this is quadrant 2, quadrant 1, quadrant 3, and quadrant 4. So end behavior is from quadrant 2, quadrant 4. The domain, as we indicated in the previous page, there's no restriction of the domain. This goes to the left forever and to the right, even though it's going down, but it's also going to the right. So we say X is an element of real numbers. Now, this is a simpler way. There's a more complete way is to have a slash with cursive line. The range now would be the same thing, except now it's Y. Get in the habit of writing this is called set notation. There's another way of writing this, which is negative infinity to infinity. So it's going from going to the left forever and to the right forever. And the bracket is a curved bracket, not a square bracket. I'll show you later on when there's a square bracket, it means the ends there. This means ending. This means there's no ending. So infinity is a concept, and the same thing for here. So infinity symbol. Now let's put this into your calculator. By the way, if you're using your Desmos, going back to here, we have our equation. So this is a little bit more straightforward. Y equals negative 3x plus 5. And you can press, oops, here we go. Yeah. Here's my, I can remove that. This is my graph now. To find my x-intercept, I tap on 1.67, which is the same as we found earlier, and your y-intercept is 5. So this is 1.67, same as what we have in our graphing calculator. Process a little bit more straightforward with Desmos to find your x and y intercept. Okay. Let's look on to one more example here. So we'll input this into our calculator. So I'll go back to y equal button, clear, and clear. Y equals negative 4. Okay, let's go back here. Example 2, y equals negative 4 in graph. No, this is negative 1, negative 2, negative 3, negative 4. 1, 2, 1, 2, negative 1, negative 2. So we have a horizontal line that goes to the right and goes to the left at negative 4. So this is moving now from quadrant So there's no graph here now. So my y-intercept would be 4. Let's verify it. Second trace value, x equals 0, y equals -4. There's no x-intercept. Okay, so we can see here, no x-intercept. Y-intercept equals -4. We can write it as 0, -4. The end behavior now, as you mentioned, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the end behavior of the slope is a horizontal line. It goes from quadrant 3 to quadrant 4. Now, is there a sign of a leading coefficient? No, because there's no slope. The slope is 0. So it has this equation as a leading coefficient of 0. Why? Because slope is equal to 0. So it's y is equal to 0x minus 4 is my equation. So that's my leading coefficient. So because your leading coefficient is 0, we don't normally write it. So we write it, leave it as x equals -4. On the example 3 next, I'll look at a couple of these here, but I would like you to, I'll go through a couple of examples here, and then make sure I got this all straight here. We can use a graphing calculator to help you here. So I'll start off with 1, the first one. I'm going here, I'm going to clear my calculator. I'll put here 0.5x plus 4. Let's do that. So y is equal to 0.5, and here's my x button. I'll have to zoom out a little bit so you can see the keypad. .5x. Now you can put 0.5x, doesn't it's the same thing there, plus 4, and a graph. Now notice this is going from quadrant 3 to quadrant 1. So we'll do a sketch of that graph. Now it crosses the x-axis. 1, 2, 3, 4, 5, 6. So we'll find it exactly where it crosses the x-axis. So we know it's going up. So to find that, so we'll do a sketch of it. You don't have to be specific in this case here. Now, from our calculator, I can tell right now is 1, 2, 3, 4 is my, and this will be 1, 2, 3, 4, 5, 6, 7, 8. Another way of finding it, we can use our x-intercept here. So the sign of a leading coefficient is positive. Notice it's positive here. It's not written. The slope direction is from quadrant 3 to quadrant 1. Be careful, do not reverse the trend, right? So slope direction is positive. Oops, this would be your and behavior. Slope direction is positive. So it's going from increasing. So this is what rises to the right, or increasing to the right. And end behavior, sorry about that, quadrant 3 to quadrant 1. Now the next one, we'll do a similar one here. To y equal button, clear that. Negative 2.2. Now just remember to use your negative sign, not your subtract sign in your calculator. Okay. So we have negative 2.2x, so we put negative 2.2x plus 12. Now, the y-intercept is 12. Now, see what happens here. I don't see anything here. Yes, I do see. But the y-intercept is way above my graph, my window. So I need to adjust my window setting. So I have to make y at least 12. So I'll go to my window button and make that y maximum. I'll make that 15. Now, that means I'm increasing my window screen, and there's my graph. I can see it going from here. By the way, always put the arrowhead if there's no restriction. You know, it's going to be 12. And this is approximately 1, 2, 3, 4, 5, between 5 and 6. Now, sign of a leading coefficient, negative. It's decreasing to the right. And this goes from quadrant 2 to quadrant 4. There are 6 here, and I'll just do the first, a few of these here. And you have y equal to negative 5 here. So this is a horizontal line. If I were to go to my calculator here and I make that y is equal to negative 5, I should have a horizontal line going through y equal negative 5. So this is my negative 4, negative 5 here. Sign of a leading coefficient. Now, the leading coefficient in this one here, in this case here, it's 0, right? So this equation is y equals 0x minus 5. So there's no leading coefficient. Okay, so no leading coefficient. Or it's 0. Slope direction is horizontal, right? No leading coefficient. Horizontal. And this is going from quadrant 3 to quadrant 4. Now, this is what I want to show you, how you input this into your calculator. It's very tricky with the calculator. So let's look at how you enter this specific one in the calculator, so using brackets. The y, let me clear my, y is equal to negative. Now, whenever you have a fraction, put that fraction in brackets. So negative 1 divided by 3. Notice what I did here. Okay, negative, let's look at here. I have my negative sign, but the 1/3, I put open bracket first. 1 divided by 3. 1 divided by 3, close bracket. You need to close that bracket. You're telling the calculator, look, I want these two values to be together. 1/3. So then I'll put another open bracket. X minus 3. X minus 1. Close bracket. So remember, you need the brackets here. Make that 1/3. Anytime you have a fraction, using a graphing calculator is so wise to use brackets. Same as Desmos, it's also good to use brackets. Now, to your graph. So we have this sketch. It's a negative, and it seems to be going through a very gentle slope. Now the slope is negative 1/3, meaning that it's not a very steep slope, but it's negative, right? So negative slope. So we say here, the standard leading coefficient is negative. Slope direction, decreasing to the right. So this is a pattern. Whenever you have a negative, it's decreasing to the right. When it's a positive, it's increasing to the right. And this is in quadrant 2 to quadrant 4. Now, for those of you who are Desmos, we'll clear that. And we'll do another one, y equals negative 1/3. And I'll use a bracket also for that, right? Negative, I'll use my bracket here. 1 divided by 3. Now, Desmos does a neat thing. Oops, go back here. Tap on it, close bracket. It gives you a nice looking fraction compared to the graphing calculator. Then I'll use my open bracket. Now, you don't have to use open bracket, but you can go ahead and use open bracket. It's a good practice. X minus 1. And I tap here, close my bracket. And that gives me my equation. The beautiful thing about Desmos, you can just tap on it here, and it'll give me my x-intercept. Tap on it here, gives me my y-intercept. That's for Desmos. Now, let's go back to the last two set of questions. X equal to 3 into x minus 8. Graphing calculator. Clear button. 3 open bracket x minus 8. Now this one gives you the bracket. Oops. 3 into x minus 8, close bracket, graph. Now this one is way out of the window, so I need to adjust my y minimum. So go to my window here, and I y minimum, make that negative 30. My y-intercept in this case, let's see what it is. It should be x equals 0, y equals negative 24. So it's negative 24. So let's do a scale. So my graph here is negative 24. And my x-intercept would be 1, 2, 3, 4, 5, 6, 7, 8, 9, approximately 9. So remember, you don't have to be precise in this case here, 9. So this is my graph here. So it's going from quadrant 3 to quadrant 1. Sign of a leading coefficient is positive. Increasing to the right. So let's go from quadrant 3 to quadrant 1. The last one in this range here is, now, by the way, sorry, I missed this one here. I forgot to use my decimals here. So let's look at this one here. It'd be the same. We have y equals, open bracket, x minus 8, close bracket. And now, did I do that correctly? No, I did not put my 3 here. There we go. So tap on it here. It gives me negative 4. If I tap on that, it gives me, it's 8. So this is 8. Let's verify it in our calculator here. So I'm going to find my x-intercept. Go press here, my y equal button, let x be 0. Second trace, find intersect. So 3 times. Yes, it is 8. So it's good to verify things. Don't just guess like what I did there. So this is 8. And the last but not least, you have this one here. Let's use our graphing calculator again. Equal button, clear that. And I'll leave, because I can find my x-intercept. I leave that as it is. 3 minus now you're going to use a subtract sign. Do not. It's only when you have a leading coefficient negative, use your negative button. Otherwise, use your it's not a leading coefficient. We write it as, if it's a calculation, be negative here. So negative. Oops, I have twice there. So 3 minus 4x graph. Notice your slope should be negative, and it is negative. So I'm going down like this here. Now notice the sign of a lowering coefficient is negative, so negative here. Be careful with this one here. You don't always have to write it as y equal to mx plus b. In this case, it's b minus mx. So in this case, it is decreasing. To the right. And it's from quadrant 3 to quadrant 4. So today, this lesson, we set out to looking at undefined characteristics of linear functions. So that's where we were. Get back my handout here. So this is our goal for today. So identify the characteristics of the linear function. Look at the linear coefficients, slope, and behavior, y-intercept, x-intercept, and domain and range. We discovered that you can find the domain and range. So we look at one example here. An equation of a straight line is y equal mx plus b. The slope direction, we'll look at what quadrant is, if it's decreasing, the graph is going down as you move to the right. If it's increasing, you're going up as you go to the right. We looked at end behavior. We look at the sign of the leading coefficient is a sign in front of the slope, the domain, and the range. Your assignment is to work on page So on page 23, I'm going to try these assignments here. And also for your hand-in assignment, it will be hand-in assignment number 2. So we end as our goal. So at the end of today's lesson, you should know the leading coefficient, the slope, the end behavior, y-intercept, x-intercept, domain, and range.